Welcome to my channel. In this lecture video, we explore a very important geometric idea that helps us understand how perceptron makes decision. We start with the expression cos alpha equals to W transpose times X over W norm X norm. This equation tells us that the dot product W transpose times X is directly related to the cosine of the angle between the weight vector W and the input vector X. Since the magnitude W and X are always positive, the sign of the dot product depends only on the cosine term. This gives us a powerful interpretation. If W transpose times X is greater than 0, then cos alpha is greater than 0, which means the angle alpha between W and X is less than 90 degrees. In other words, the input vector is pointing roughly in the same direction as the weight vector. If W transpose times X is less than 0, then cos alpha less than 0, meaning the angle is greater than 90 degrees. Now the input vector points in the opposite direction to the weight vector. This geometric viewpoint helps explain how the perceptron classifies points. On the other side of the slide, you see two groups of points. The blue vector P1, P2, P3 represent positive sample. The red vector N1, N2, N3 represent negative sample. The dashed line represent the equation W transpose times X equal to 0. This is the perceptron decision boundary. Everything on one side of the line has a positive dot product with W, meaning the angle between W and those vectors are acute. These belong to the positive class. So points P1, P2 and P3 fall on this side. Everything on the other side has a negative dot product given an angle greater than 90 degrees. This corresponds to the negative class, which is why N1, N2 and N3 lie on that side. So this visualization beautifully shows that classification is really about the angle between the input vector and the weight vector. If the input points in the same general direction as W, the perceptron labels it positive. If it points away from W, it labels it negative. This geometric institution is central to the understanding perceptrons, linear classifiers, and even more advanced deep learning models.